Hi guys, so we're ready to start the last chapter in the class, chapter 10, which is on quadratic equations and functions. So section 10.1 is titled Square Root Property and Completing the Square. In concept 1, we're going to solve quadratic equations using what's called the square root property. But before you jump into that, I recommend I posted 2 videos just to kind of review what imaginary numbers are. So I would look over that. So in the class, we skipped the last section of chapter 9. So that's not typically in this class with Ohio State over complex numbers. And they talk a little bit about imaginary numbers in there. And the focus is on complex numbers. It's a little bigger than that. But since we didn't cover that, I just want you to review that a little bit just so you're comfortable and aware with that. So review imaginary numbers videos on Carmen. Right? So it should be right above this video, right? So just some things just to kind of get us thinking. What I want us to think about is how do I solve maybe x squared equals 25 and x squared equals negative 25, right? So like if I think about x squared equals 25 and I try to think about, what are all the possible x values that I square to get 25, you should be realizing that if I take 5 squared and also negative 5 squared, these both equal 25. Right, so when I take something to a square something, I lose what sign it had originally, right? Because if the original thing was positive or negative, if I square it, I get a positive value back, right? So in other words, kind of the thinking is if I have x squared equals 25, then I can take the square root of both sides, but I need to put a plus or minus in front of one of the sides, right? So in other words, x equals plus or minus the square root of 25, which is x equals plus or minus 5, because the square root of 25 is 5, right? So similarly, if I want to solve x squared equals negative 25, I could take the square root of both sides, right? But we can't have the square root of a negative value, right? At least it's not a real number. So that's where an imaginary number comes along, right? Because we have what's called I, which equals the square root of negative 1, right? We have this imaginary unit. So we need to put a plus or minus on one of the sides. So what we end up getting is x equals plus or minus the square root of negative 25, which equals plus or minus the square root of negative 1 times the square root of 25, right? So just splitting that apart using the multiplication property of radicals. So then this would equal plus or minus. So this would be I times 5, right? Or in other words, x would equal plus or minus 5i, right? Typically we write like the I last when simplifying that, right? And I know that because, this part, I equals square root of negative 1, and square root of 25 equals 5. So I was just substituting those values in, right? So that's just kind of like a rough idea of what we're doing. So let me write this up a little more formally. So this is called the square root property. So for any real number k, if x squared equals k, then x equals radical k, or x equals negative radical k. Right? So we could say, note, the solution may also be written as plus minus radical k, and that's read as plus or minus the square root of k. Right? So that's the square root property. So I have some examples solving quadratics with this square root property. So the first one, we have 25a squared equals 16. Right? So the first thing I could do is divide both sides by 25. And I get a squared equals 16 over 25. And then now if I take the square root of both sides, remember I got to put a plus or minus in front of the sides. So that gives me a equals plus or minus the square root of 16 over 25, which equals plus minus the square root of 16 over the square root of 25, right? So remember that's the division property of radicals, which is equal to plus minus 4/5. Radical 16 is 4, and radical 25 is 5, right? So the solution set, is 4/5 or negative 4/5, right? But we could also write that as plus minus 4/5, right? Either way. Example 2, we have 8x squared plus 72 equals 0, right? So the first thing we want to do is isolate the item that's squared. So we would subtract 72 from both sides and get 8x squared equals negative 72. Divide both sides by 8, and I get x squared equals negative 9. And then when I take the square root of both sides, I'm left with x equals plus minus the square root of negative 9, which that equals plus minus the square root of negative 1 times the square root of 9, which equals plus minus 3i. Right? So in other words, my solution set is plus minus 3i. Right, so those are two imaginary solutions. Right, so then example 3, we have t minus 5 quantity squared equals 18. So notice on the left-hand side, we already have something squared. So I can apply the square root property and take the square root of both sides. So that leaves me with t minus 5 equals plus minus radical 18. Right? And, radical 18 can be thought of as radical 9 times radical 2, right, using the multiplication property of radicals, which that is just 3 radical 2, right, to simplify that. So we would have t minus 5 equals plus minus 3 radical 2. So if I add 5 to both sides, I would have t equals 5 plus minus 3 radical 2. Right, so the solution set for t is 5 plus minus 3 radical 2. Right, so notice I just added 5 to both sides and I was able to write it like this. If you don't like using that method, right, what you could do is you could say t minus 5 equals 3 radical 2, or t minus 5 equals negative 3 radical 2. So you could split it up apart and then add 5 to both sides. We get t equals 5 plus 3 radical 2, and t equals 5 minus 3 radical 2. So notice we end up getting the same thing. Right? Excuse me. All right, so example 3 was to prep us for an idea really to think about completing the square, right? So in example 3, we solved t minus 5 quantity squared equals 18, right? So note that t minus 5 quantity squared is equal to t minus 5 times t minus 5, which if we FOIL this, we get t times t plus negative 5 times t plus negative 5 times t plus negative 5, negative 5 times negative 5, which that simplifies to be what, t squared minus 10t plus 25. Right? So in other words, this would have been similar to solving t squared minus 10t plus 25 equals 18. Right? So I just substituted t minus 5 squared for what what it looks like, multiply it all out. Right? So so basically, this is going to be another technique that we can use to solve quadratic equations, right? So a new technique for solving quadratic equations is by completing the square. Right? So if I have x squared plus bx plus n, this is a perfect square trinomial if n equals 1/2 times b quantity squared, or or equal to b divided by 2 quantity squared. Right, so our book does 1/2 times b quantity squared, but I think it's easier just to do b divided by 2, b divided by 2 squared. Right, so what we could say essentially is that x squared plus bx plus b divided by 2 quantity squared is equal to, this factors a b, x plus b divided by 2 quantity squared. Right, so this is something good to know that can help us, especially in the next example, or in this section. Right, and just to note that in order to get this part, we can add that to both sides to make that happen. Right. So example 4, we're asked to determine the value of n that makes the polynomial a perfect square trinomial, and then we want to factor it. So n is going to be equal to b divided by 2 quantity squared. So b is always the coefficient for the variable raised to the first power, right? So this would be 20 divided by 2 quantity squared for this first one. So 20 divided by 2 is 10, so this would be 10 squared, which is 100. So we want n equals 100, right? So if I fill that in, then this is going to be equal to x plus 10 quantity squared. All right, so remember we just, b divided by 2 is going to go here, right? All right, so the next one we have n equals b divided by 2 quantity squared, which in this case b is actually negative 16, right? Because, it's always, for a quadratic, right, it's x squared plus bx plus c, right? And that's if this leading coefficient's 1. If the leading coefficient is not 1, so like a, then we get this, right? So if we have like here if we have like y squared minus 16y plus n, then this would be like y squared plus negative 16y plus n, right? So hence b is equal to negative 16, right? So this would be negative 16 divided by 2 squared, which equals negative 8 squared, which equals positive 64, right? So n equals 64. And then if I fill that in, this is equal to y plus b, so that would be minus 8 quantity squared, right? Because b divided by 2 is negative 8, right? Right, so the next one, we would have, n equals b divided by 2 quantity squared, which is equal to negative 5 divided by 2 quantity squared, which equals 25 fourths. Right, so n equals 25 fourths. So if we fill that in, that would factor to be a minus 5 halves quantity squared. Right, because remember, we want to put this part in there, right? B divided by 2. Right, so then the last one, we have n equals b divided by 2 quantity squared, which this would be 7/3 divided by 2 quantity squared, which equals, this would be 7/6, right? We can multiply top and bottom by half, right? So if you forget how to divide fractions, right? If I have 7/3 divided by 2, that's the same thing as 7/3 times the reciprocal, right? Times 1/2, which is 7/6, right? So then when I square this, I have to square the top and the bottom, right? So this would be 7 squared over 6 squared, which equals 49 over 36. Right, so n equals 49 over 36. If I fill that in, this factors to be w plus the b divided by 2, which is 7/6. Right, that was here. Right. All right, so now I want to review, the steps for solving an equation in the form ax squared plus bx plus c equals 0 by completing the square, and we're also going to apply the square root property. So number 1 is you want to get rid of the leading coefficient. We want to make it 1, so we divide both sides by a, and then you're going to isolate the variable terms. So, essentially we're going to remove everything without an x, right? And then you're going to complete the square. So we're going to add, b divided by 2 squared to both sides. Then you're going to factor, and then apply the square root property. Right? So have one to start with. We have, whoops, don't want to write that with a highlighter. We have z squared minus 4z plus 26 equals 0. Right, so step 1 I don't have to worry about because the leading coefficient's already 1, right? So then the next thing, I want to get rid of everything without a variable. Right, I want to isolate it, get just those by itself on one side. So subtract 26 from both sides, we get z squared minus 4z equals negative 26. And then we want to figure out what b divided by 2 quantity squared is. And that is negative 4 divided by 2 squared, which is 4. Right, so I want to add 4 to both sides. Right, and don't forget, you do have to add the value to both sides, right? That's the addition property of equality. You have to add things to both sides. You're going to change the equation, so we want to keep that balance. So we get z squared minus 4z plus 4 equals, so negative 26 plus 4 is negative, what, 22? And then I can factor the left-hand side. That becomes z minus 2 quantity squared equals negative 22. So then now I can take the square root of both sides. And don't forget, we got to add a plus minus in front. So the left-hand side would simplify to be z minus 2 equals plus minus the square root of negative 22, which this is equal to, if we simplify this, this would be, square root of negative 1 times square root of 22, which is equal to plus minus I radical 22. Right? So in other words, what we have is z minus 2 equals plus minus I times radical 22. So then I could add 2 to both sides. So what I get is z equals 2 plus minus I radical 22. Right? So those are my values in my solution set. Right. All right, so then I have two more problems to try with completing the square. So the first one, we have 4x squared plus 12x equals 5. Right? So the very first thing I want to do is divide both sides by 4. So this is 4x squared divided by 4 plus 12x divided by 4 equals 5 divided by 4. Right? So 4x squared divided by 4 is just x squared. 12x divided by 4 is 3x. And then I'll just leave that as 5/4. Right? So now what I'm thinking is, what's b divided by 2 quantity squared? So that would be 3 divided by 2 quantity squared, which is 3 squared divided by 2 squared, which is 9/4. So that's what I want to add to both sides in order to complete the square. Right? So I get x squared plus 3x plus 9/4 equals, and then 5 plus 4 is 14, right? So this would be 14/4. And then that can simplify to be 7/2. I can divide top and bottom by 2. So then the left-hand side will factor to be x plus 3/2 quantity squared. Right? Because remember, we take b divided by 2, and that's going to go there. That's equal to 7/2. So now's where I apply the square root property. So I can take the square root of both sides. We got to put a plus or minus on one side. So I'm left with x plus 3/2 equals plus minus the square root of 7/2. So I want to simplify this. Remember, I can't take the square root of I can take the square root of a fraction, but we don't want a fraction in the radicand for it to be simplified. So this is equal to plus minus radical 7 over radical 2. And then I can rationalize the denominator, which this gives me plus minus. So with the top, I can use the multiplication property of radicals, and that's going to give me radical 14. And then radical 2 times radical 2 is just 2, right? They cancel each other out. It's like radical 2 squared. So what I have is x plus 3/2 equals plus minus radical 14 over 2. So then if I subtract 3/2 from both sides, I get x equals negative 3/2 plus minus radical 14 divided by 2. Right, so there's the solution. All right, so the next one's a little more work. We have 2y times y minus 1 equals 3 minus y, right? So I want to get it to look like that trinomial form, like ax squared plus bx plus c. So the first thing you're going to want to do is distribute the 2y through. So that gives me 2y squared minus 2y equals 3 minus y. And then I'm going to add y to both sides. And I'm not going to worry about the 3 because I'm going to have to pull that to the other side anyway and isolate everything with a variable. So I'm just going to get all my y's to one side and leave the 3 on the right. So that gives me 2y squared minus y equals 3. And then now remember, I want to get a leading coefficient of 1, so I could divide both sides by 2. So that leaves me with y squared minus 1/2 y equals 3/2. And then now's where I want to complete the square. So just note that, b divided by 2, maybe I'll do this a little down here, b divided by 2 quantity squared is equal to negative 1/2 divided by 2 quantity squared, which negative 1/2 divided by 2 is negative 1/4 quantity squared, which equals negative 1 squared over 4 squared, which is 1/16. Right, so I want to add 1/16 to both sides. So this gets me y squared minus 1/2 y plus 1/16 equals, and then so 3/2 is the same thing as 24 over 16, right? If I multiply the top and the bottom by 8. So 24/16 plus 1/16 is 25/16. Right? So then the left-hand side will factor to be y minus 1/4 quantity squared, and that's equal to the 25/16. So then I can take the square root of both sides, put a plus or minus on one side. We're left with y minus 1/4 equals plus minus radical 25/16, which that's equal to radical 25 over radical 16, which equals 5/4. Right? So y minus 1/4 equals plus minus, I forgot the plus minus here, plus minus 5/4. So if I add, I'm going to actually split this apart. So we would have y minus 1/4 equals 5/4, or y minus 1/4 equals negative 5/4. So if I add 1/4 to both sides, I get y equals 6/4, which is equal to 3/2, or y equals negative 4/4, which equals negative 1. Right, so the solution set is 3/2 or negative 1. So then concept 3 is looking at some literal equations. So it's kind of like some applications, if you will. So we have the formula for the area of a circle is a equals pi r squared, where r is the radius. We want to solve for r, and we're told do not rationalize the denominator, right? So don't worry about rationalizing to simplify that. So if I just write what we have a equals pi r squared. I want to try to solve for r, so if I want to divide both sides by pi, and what that gives me is a divided by pi equals r squared, and then I can take the square root of both sides, and I have to put a plus or minus in front of one side, right, if we're in general. So what that gives me is plus minus the square root of a divided by pi equals r, right? But something to note in this context is that r is always positive, right? A radius is a measurement, a length, right? So actually this part should be just positive, right? So really r should be equal to the square root of a divided by pi, right? So that's solve for r. So then now what we're asked to do is to use this equation from part A to find the radius for a circle with an area of 15.7 centimeters squared. Use 3.14 for pi and round to 2 decimal places, right? So we're using this equation and just plugging some values in. So this would be 15.7 centimeters squared divided by 3.14, what we're using for pi. So if I simplify this, this ends up becoming the square root of 5 centimeters squared, which equals radical 5 centimeters, which this is approximately, if we just rounded 2 decimal spots, it's 2.24 centimeters, right? So as we were asked. Right. All right, so so that's the notes for this section. Make sure you let me know if you have any questions.